All right, so here is where we left off in the previous video. So now that we have a formula for converting to polar, now we can go ahead and solve this equation that we did 2 videos ago. So we want to find the volume of the region that is enclosed by the graphs z equals 16 minus x squared minus y squared, and z is equal to 3x squared plus y squared. So let's just recall what happened. So you can see that this guy was just a paraboloid shifted up 16 units and it was going downward. And then this other guy is another paraboloid, but it's centered at the origin and it's going upward. And remember that we had a region in between where both of these guys met. And if you remember, that region itself was the region x squared plus y squared equals 4. So just to remind you what the region looks like, it's just a circle of radius 2. All right, so, and remember that in Cartesian coordinates, when we were trying to take the integral of this guy, it was super difficult to do, right? Because if I were to do it case 1, you would have to do the bottom part of the circle, which was the negative square root of 4 minus x squared, and the top one, which was the positive square root of 4 minus x squared. So that was really difficult to go ahead and calculate. So now what we're going to do, let's go ahead and set up the integral just how we did before. So we had the double integral, and I'm just going to say over the region R. We're going to call this region R. And it's going to be of the upper minus the lower. So that's what we had before. So upper minus the lower paraboloid. And I'm going to write dA. So this is going to be the double integral over the region. The upper one was just a 16 minus x squared minus y squared, minus the lower one, which is 3x squared plus 3y squared. And this is going to be dA. All right, so now let's go ahead and convert to polar coordinates. All right, so what we're going to do here is convert to polar. And you'll see how easy this is going to be. So now the first thing, before we talk about the limits of integration, let's go ahead and use the unit conversion. Now remember that x is equal to r cosine theta and y is equal to r sine theta. And we also know that x squared plus y squared equals r squared. So you can see here that we can use the formula for x squared plus y squared equals r squared. So this first guy is going to be 16 minus r squared. And that's just because x squared, negative x squared minus y squared, you can factor out a negative. That's where this negative came from. And x squared plus y squared will be r squared. And now we're going to do the same thing here. You can factor out a 3. And you're left with a x squared plus y squared. That's going to give me r squared dA. Well, let's just not write dA yet. All right, so we have something that reduced it. Okay, so it made it a little nicer. Remember, since we're changing to polar coordinates, dA is going to be r dr d theta. And now all we really got to do is convert this entire circle into polar coordinates. So our radius is going to be from 0 all the way to 2, right? Because it starts from a radius 0 all the way to a radius 2. Okay, so if you kind of think of infinite little circles, you can think of that going from 0 all the way to 2. So this guy's going to go from 0 to 2. All right, and now we got to think of theta. Now theta, we want the whole circle, right? So it's going to start from 0 all the way to 2 pi. 0 to 2 pi. All right, so now that we have that, now we can go ahead and find this integral. And this integral is going to be equivalent to the integral that we were trying to figure out 2 videos ago. So this is going to be the integral from 0 to 2 pi. The integral from 0 to 2. This is going to be 16 minus 4r squared times r dr d theta. I'm going to FOIL this r inside. So you get the integral from 0 to 2 pi, integral from 0 to 2 of 16r minus 4r cubed dr d theta. All right, and now all we're going to do is just take the antiderivative. So this is going to be the integral from 0 to 2 pi. So we're going to use this integral first using iterated integrals. So this is going to be 16r squared over 2, which is 8r squared. Then for r cubed, that's going to be minus r to the 4th power from 0 to 2. All right, so now this guy is just going to give me 0 to 2 pi. 8 times 2 squared minus 2 to the 4th d theta. So this equals the integral from 0 to 2 pi. What would that be? So it will be 4 times 32 minus 16 gives me 16. So 16 d theta. Now take the antiderivative of 16 with respect to theta. That's 16 theta from 0 to 2 pi. So you get 16 times 2 pi minus 0, which gives me 32 pi, which tells me that the volume enclosed by these two paraboloids, so all of this volume here, okay, is basically 32 pi. This guy's the volume, so you can write units cubed if you want. All right, so now let's go ahead and do the next problem, and you can see that this was a lot easier integration than the other one. So now let's go ahead and do this example. So let's say we want to find the double integral over the region D of e to the x squared plus y squared dA, where D is a unit disk centered at the origin. All right. So here we're going to integrate this thing over the unit disk. So if you kind of think about it, the graph, I don't know what e to the x squared plus y squared looks like, but let's just pretend that it looks something like this. And the region is going to be a circle of radius 1. And we're kind of projecting this circle on here, and we want to find this volume. Okay, so let me write it in the 2D case. Let's write the region. So it's a circle. It's a unit disk, so that means it's a circle of radius 1. So all we got to do is just take the double integral. So we got the double integral over the region D, e to the x squared plus y squared dA, which is a super difficult integral to do, okay, because there is no closed form for e to the x squared and e to the y squared. So converting it to polar will be super nice. So we know that x squared plus y squared is just equal e to the r squared, right? Now dA in this case is going to be r dr d theta. And now what would my limits of integration be? Well, r is a circle of radius 1, so it goes from 0 all the way to 1. So it goes from 0 to 1. And we want the entire circle. So it's going to go from 0 to 2 pi. Be very careful because sometimes they won't ask you for the whole circle. They might tell you like the first circle, the circle in the first octant, right? So they might just want a piece of the circle. So in that case, it'll be from 0 to pi over 2. All right, so now we have something that will be a lot easier to work with because now we have this extra r and we can just use u substitution. So I'm going to let just u be r squared and du is going to be 2r dr. So we have 1/2 du equals r dr. And we're just going to substitute these guys in here. So we're going to have the integral from 0 to 2 pi. The integral from 0 to 1. I'm going to write r here to let you know, hey, this is going to be an integral with respect to r. Okay? And then we're going to have e to the u. R dr, that's just equal to 1/2 du. And then d theta. Okay, so the reason why I'm writing r is because these guys belong to r, not to u. You can always do a change of variables and change the u variables back to r, but I'm just going to leave it as is. So I'm just going to have the double integral. I'm going to pull out the 1/2 actually. The integral from 0 to 2 pi. Integral from 0 to 1, and these guys belong to r. We got e to the u du d theta. So the integral of e to the u is just e to the u. So this just stays the same. And now let me do a substitution back. So let me just plug in my u back. So I'm going to have 1/2 integral from 0 to 2 pi. And this is going to be e to the r squared from 0 to 1. And I can go ahead and get rid of those equal r because now I plugged it back in there. So I'm going to have 1/2 integral from 0 to 2 pi. This is going to be e to the first power minus e to the 0 power, which is just going to give me e minus 1. And e to minus 1 is just a number that I can plug into the calculator. And then taking the antiderivative of that with respect to theta will be e minus 1 times theta from 0 to 2 pi. And all I really got to do is plug in 2 pi. So you'll have 1/2 e minus 1 times 2 pi, because the other stuff is just going to go to 0. And you can see that the 2's will cancel out, and you're left with pi e minus 1. So this will be the volume of this region, okay, of this guy. All right. All right. So later on in class, we will do some more complicated ones where now you have 2 circles and you want to look at this annular region. So we will do that in class.